The citation for that medal is for his contributions to partial differential equations, combinatorics, harmonic analysis, and additive number theory, 4 distinct fields in mathematics. He's been called the Mozart of mathematics, but to my mind, it's actually more useful to refer to math's own prodigies in terms of the number, the range, and the impact of his contributions. Terry advised comparison to Carl Friedrich Gauss and Leonhard Euler. He is, in short, the genuine article. Today, Terry will be telling us about structure and randomness in the prime numbers. Terry.
Thank you very much. Nice introduction, Joe. It's good to actually speak in my home university for a change, even if the weather wasn't quite what I remember it to be. But anyway, so I'm going to give a talk, not so much on my own work actually, but on a field that I work in, number theory, one of the 4 fields Joe mentioned. So number theory, and specifically in the study of prime numbers, which is a very significant slice of number theory. And this is a very old topic. 2,000 years of research has gone into this topic, and I'm not going to talk about all of this in 1 hour. So just a whirlwind tour, so the equivalent of going through, Paris and just seeing the Eiffel Tower and the Arc de Triomphe and so forth. But not really giving it's impossible to give more than just a taste of the type of things that are going on. But I just want to convey that this is a lot of work has gone into this. We know a lot more than we did 2,000 years ago, but there's still a lot more to be done, and it's still a very exciting field with lots of discoveries, every year basically. So we're talking entirely about the prime numbers. So you all know what a prime number is. I'll just review the definition. A prime number is a natural number larger than 1. Which cannot be split up as the product of 2 smaller numbers. So 2 and 3 and 5 are prime, but 4 is not, because 4 is 2 times 2. You converse to 20 or 30 prime numbers here, and so there they are. So why do we care about these numbers? Well, one way to think about them is that they're sort of the analog of atomic elements in chemistry. They're sort of the fundamental building blocks of multiplication in the natural numbers. And this comes from one of the first theorems about primes, dating back to Euclid, 300 BC, which is the fundamental theorem of arithmetic, that any natural number bigger than 1 can be expressed as the product of 1 or more primes. So it's just like every molecule can be expressed in terms of atoms, every natural number can be expressed in terms of primes, and furthermore, there's really only one way to express each number in terms of primes.